Um, Hello y'all. I just want to make a quick video, or it might not be quick, but I just want to make a video about hash tables and a method that I found easy to understand and learn. Um, so essentially, hash table is a vector. The way I like to think about it is either a vector and array, where if two things are indexed in the same index, so say if one here and um, our second element, so 2, um, are indexed in the same spot, we create a linked list um, to both of these. So we can store multiple items in the same index by creating a linked list, and this can go for all elements in, or all indexes in this array. So yeah, first off, we're going to have to start off with including vector, and we're going to define our table size. Table size is equal to 10. Const. I believe from my research, people usually set these table sizes to a prime number. I'm not sure if 10 is a prime number or not, but we're just going to keep it like that for now. So like my other videos, it's going to implement a lot of the linked list ideas and fundamentals from my previous videos. So we're just going to create a class called user. And in this user class, we can input a string name, string ID. So we're just going to input two items or two things for this user. We're going to make this private because we don't want this being changed. And then in our public part, just like before with we're going to have a next pointer of data type user. Next, null, make this null PTR. And then our last, make this null PTR as well. And then we're going to have setters and getters. So we're going to have a get string get name, and then we're just going to return name, string get ID, and then we're going to return the ID. And then we're going to have a void set name, which is going to input, we're going to input a string name as a parameter. And then we're going to say this name is equal to name. Just setting whatever name we put in into this parameter is going to be set into for this one right there. Void and then void set ID. We're going to input a string as well called ID, and then we're going to say this ID is equal to ID. We don't need these two brackets, sorry. So this is pretty much it for this user class. So let's move on to the hash table class. So class, we're going to say class hash table. So in this class, I'm just going to go over the hash function, adding the user and printing the users in the hash table. So we're going to declare a vector of type user, which is going to be they're going to be pointers. So we're going to point to just a pointer vector of type users. table, just call it table. So we have that. Oh, we're going to make this private, sorry. We don't want people changing this as well. Private. And then in our public functions, we're going to make a constructor, hash table, table dot resize, sorry, I forgot these. Table dot resize. So we're going to resize whatever our table is by our table size from up top right here. So once we declare a hash table instance in here in the main, it's automatically going to change the size of this table, this vector called table, to the size of 10, right? So now we're going to go over the hash function. So I'm going just to hash the whatever the ID is, so whatever string is inputted for the ID. And this function is going to be of type int because we're going to be returning a number, and this number is going to give us the index that we have to index whatever this person is in the hash table, right? So it's going to give us the number to put in this vector, right? So we're going to say int hash function, and then we're going to input a data type user, and we're going to reference the user. So we're going to reference it so we can get access to their string ID. So we're going to say this, and then we're going to say int key is equal to 0. This is what's going to hold our let me just change it to hash key for now. Hash key is going to hold our whatever the index is after we do the calculations on the ID, right? So we're going to do a and then hold up, std string user ID, and user ID is going to hold user dot get ID. It's going to hold whatever our inputted user's ID is, right? So here we're going to do a for each loop. So for char ch, I'm just going to call it ch, you can call it whatever, user ID, hash key plus equals ch. So we're just going to go through the whole string character by character. Just say this is the ID. Character by character, add whatever this value is whatever this value character 1 is as a number, add it to hash key, then do the same thing for this one, then move on, do the same thing for this one, then do the same thing for this one. And that's what hash key is going to hold. And then we're going to return the hash key modulo whatever our table size is. So that gives us the index. Oh, I spelled this wrong. There we go, table size. So that's going to give us the correct index to input this user in based on their ID. So then we're going to have a void add user, which is just like the linked list before, very similar to the linked list videos before. We're going to have a data type user, not pointer, reference the user, whatever user we input. And here we're going to declare int key, which is going to hold the this key integer value is going to hold the whatever the index is for a vector. So we're going to say int key is equal to hash function user. So what we're doing here is we're going to call, before even executing everything else, we're going to call the hash function, do the calculations, once we get the correct number, or once we get the number for the index, we're going to input that into key. So now key holds whatever this calculated it to be, right? Int key, and then we're going to have a user data type called entry, new user. So this is just going to be a pointer to just this new user, right? So to input it into our hash table at the current key, we first got to check if the index based on key in the table is empty or not. So if in this key, this current index based on key is empty, we're going to say if what do we call it? Table at array key at index key, sorry, not array, is equal to null. So if there's nothing at that current key, we're going to say hash. Uh-oh, we forgot another equal signs. Not hash, sorry. Table key. Table at index key is equal to entry. We're going to input entry into this current key. Else, we're going to declare another pointer of user current. So this else is if at this current key is already full. So if there's already somebody inputted in this current index, we're going to say we're going to cycle through it and then find the last person and then add them. So link them to the last person. And current is equal to table at array key. So current is going to point to the first element or the first user at this index in table. Then we're going to declare a while loop. So while current does not equal null PTR. Oh, not new, null PTR. So while there is current elements in this linked list, current is equal to current next. So in this one, what we're saying is, just do this real quick. In this vector, if say right here is 1, if we want to input user number 2, and they just happen to fall into the same index as user 1, or let's just start off from the beginning. If user 1's index is indexed at 0, 1, 2, 3, is indexed at 0, 3, is indexed at index 3, we're gonna, in this if statement, we're gonna check if key. So if table at array key, our key is 3. If it's empty, based on this, if it's null PTR, in this case it is empty, we're gonna input our entry into this. So 1 is inputted. Now say we're on to user 2. If user 2 happen to have the same index as this person, we're gonna say we're gonna declare a current pointer to point to the current array index. So current is pointing here at 1, and while current isn't null, in this case it's not null, we're going to say current is equal to current.next. So cycle through however many people are in this index, and in that index, and then once we reach the end of the index, so once we reach the end of the linked list, we're going to say current next is equal to the entry. So use the current's next pointer to point to the entry, to the new entry, and then entry's last pointer to point to current. So what this is doing is, say we want to input 2, right? Sorry, not 2, our second user. We're going to cycle through here. Since 1 is, it's not null right now, we go to current.next. Current.next in the first loop is null since we don't have anybody in here just yet. Since it's null, we say current.next is equal to entry. Our new entry is 2, and then we're gonna say entry's last. So the last pointer, 2's last pointer, point back to current, which is 1. Now, this might be a bit confusing, but essentially it's just doing this. This is another example. All these guys are linked together. Imagine all these guys are in the same index value right here, right? We're going to say while current does not equal null, we have 1 in here, so it means it's not null. It means there's elements in here. We say current is equal to current.next, so keep on cycling to the next element. Boom, 6. 6 is equal, the next point is null since there's nobody here. Then we say current, 6 is our current, so current dot next is equal to the 7th user, to the entry, so 7 is our new entry. And then we say entries last, so 7's last point back to current, which was 6. Essentially making it a doubly linked list like this, right? So that is for our add user. Sorry, I forgot to do this. While current.next does not equal null. While current.next doesn't equal null, which keeps on cycling it, right? Yeah. Sorry about that. Why? There we go. Okay, that is our add user function. Now we want to do a let's do a print user function. So we're going to say void print users, which is not going to take any parameters. Add user, hold up, I had another function before, but I forgot what it was. Let's just leave it like this for now. Yeah, okay. Print users. For this one, we want to cycle through all the indexes in the table vector, right? So in this case, we have 10 slots in our table vector, right? So we want to go through each of these little boxes and find out if there's more than one, if there's anybody inputted at that current index, right? And if there is one or more people, cycle through, if there's a linked list, cycle through the linked list and print everybody within that linked list, right? So we're gonna say what are we gonna say? User. Oh no, we're gonna do a for loop. So for int I is equal to 0, I is less than table size, I plus plus. So what this is doing is, say we only have 1, 2, 3, 4, 5 indexes in our array. If we have 1 here, 1 user there, and then this is, there's 2, oh sorry, 2, and then this is our 3rd user. 4, and let's just make this 5. Sorry, I just want to make it so I can show you guys what's happening here. 6, 7. So what this is doing is, here we have user 1, 2, 3, 4, 5, 6, 7, right? We're going to cycle through each index within table, right? And remember, since we did table.resize, it should be 10, but I'm just keeping it as 1, 2, 3, 4, 5 for now. So say this is 5, right? So for int I is equal to 0, we're going to start off at the first index in the table. We're going to, if there's any users, print. If there's a linked list, print everybody within this linked list. Once we finish printing everybody in this current index, oh, it's just not going to work if I do. Once we finish printing everybody in this current index, move on to the next index. There's nobody here, we move on to the next index. There's nobody here, we move on to this index. We check, oh, there's people here. Does this person's next point to somebody else? Yes, it does. Print this person as well. Does this person's next point to somebody else? No, this is a null. So we stop printing, move on to the next index. Is there somebody here? Yes. Check if their next pointer is pointing to somebody. Yes, there is. We print the 6th user. Check if the 6th user's next is pointing to anybody. Yes, it is. It's pointing to the 7th user. Check if the 7th user is pointing to anybody else. No, it's not. So we stop, we break, and we stop printing. So right here, we say so this is what this for loop is doing, and then we're going to say user current is equal to the table at the current index, right? So while, and then we say while current does not equal null. So as long as there's people in that current index, we're going to say std cout, let's just say name current, dot get name followed by ID and current dot get ID. And then I want to, just as an example, just to show how this is working, we're going to say indexed at and then just say I and L. So this is going to show us where exactly in the table the person is being indexed at. And then we say current is equal to current next. So once we find, if we find somebody here, so we print out ones, everybody, all of the user one's information, and then if they have a next, move on to the next. Since they do have a next and current is not null right now, we print out number 2. Current.next is null. We stop. This is gone to 1. This is the first index. There's nobody here. I++, move this to 2. There's nobody in this one. I++, 3. We're at the third index. Print them out. Does their next is current's next pointed to somebody? Yes, it is, pointing to 4. We print them out again. Is 4's next pointing to somebody? No. We break out of this. Move this to 4. And now we're at this one right here, number 5. We print out 5's information. Go on to the next. 6. We print 6 information. Go on to the next. We print 7's information. Go on to the next. 7's next is null. And we break right there, right? So that's what this is doing. So that's essentially just the add user and hash function and print user. I'm going to add some other functions later, but let's show that this works. So hash table, create an instance of hash table. Yes, that's public. Okay. And then we're going to create some users. So user1. Let's copy this. Let's just create 5 users. 2, 3, 4, 5. User 1 dot set name. Let's just call it me, Yvonne. User 1 dot set ID. Just say whatever. Let me copy this. We have 1, 2, 3, 4, 5. Okay. Adani, user Adani. This is their ID. David. This is their ID. User Mazda. This is their ID. User Barbie. This is their ID. Right? And yeah. So now we're gonna add them to the hash table. So we say hash table dot add user, user1. Let's copy this. 2, 3, 4, 5. 5, 4, 3, 2, and 1. So now they should be added to the table. And now we're going to say hash table dot print users. And now let's see if this works. Uh-oh. Sorry, I'm being really silly and just realized what I was doing wrong. I totally forgot to change these guys. These guys' numbers. 5 and 5. So now this should be able to work, and then if we run it, there we go. So here we can see that Danny was inputted at, based on their ID, was inputted into index 2. I was indexed at 3. David is indexed at 4. Barbie was indexed at 5. Mazza was indexed at 7. I want to show a collision real quick. So we're just going to change this to 1, 2, 3, 4. 1, 2, 3, 3, 4. And if we run it, since we both have the same ID now, as you can see, based on our hash function, function, we both, me and David and I, would have the same key. And as you can see here, this works. I am inputted, and then we are linked list together, so we are connected together at the same index because of our ID. But we can change this, so if we have different IDs, we would still be linked list together. So let's just say our table size was 3, just in this example. As you can see, there's more collisions. Let's just change it to 4 actually. As you can see, based on our hash table size, even if we have different ID numbers, we can be indexed at the same index, right? Of course. So here in this first run, Donnie's ID, she was indexed at number 2, and now she's indexed at place 0. David was at place 3. Now they're linked list together in the 0th index. I and Barbie are now indexed at the first index, and Maz is by himself in the 3rd index. So you can see that it's handling collisions just fine. And if we make this into 20, we all should have our own index, as you can see right here. So depending on how big your table size is, that's it's gonna be more spread out, your index values. So let's just change this back to 10, and as you can see, we're back to normal again. So thank y'all for watching. This was just a short little, well, not short, but just wanted to go over this hash table that I found a not very easy to learn, but understandable to an extent. Let me know if y'all understood it, or if there's anything I should add, change, or clarify. I'd be happy to do it. Thank y'all for watching.